Okay, welcome everyone to this webinar on the proposal for a good practice for an alternative encoding based on GeoJSON. My name is Michael Lutz I'm from the European Commission's Joint Research Center, and we've been coordinating this work of the subgroup under the Inspire Maintenance and Implementation Work Program, number 2017.2. That's the name of the action. And we want to basically present to you today the outcomes of the work that we've been doing over the past year or so. We have with me today as well Thorsten Reitz from WeTransform, who will be doing most of the presentations today, who's been a contractor working with us on this action and doing most of the editing work on the documents that we want to present to you today. So let's get started. Before we get started, maybe just a bit of housekeeping. Please mute your microphones if you have them, so that we don't have any background noise. Later, if we have a discussion and if you have questions or you want to basically make a comment, please use the raise your hand option to indicate that you want to speak, so that we have an idea of who's speaking. We've quite a lot of people on the call today that I'm quite happy to see. So it will not always be easy for me to see everybody immediately raising their hands, because I don't have everybody on one screen. But I'll do my best to try and get everybody to ask their questions or make their comments. Okay. Then let's get started. As I said, we have this action 2017.2 on alternative encodings. And why have we been doing this? So the context for this activity was basically that we've seen over the years with Inspire implementation that the Inspire data is not easy to use in standard GIS systems, because the technical guidelines that we have for the Inspire data specifications, they define complex data structures and existing applications. That's basically GIS clients, mobile, desktop, but also web clients, or libraries like GDAL. OGR, they have difficulties to consume these contexts, including the complex data structures. Now, in the data specifications, we have a standard default encoding, which is GML, and that basically reproduces these complex structures that we have in the UML data models, in the conceptual data models. But the framework has basically been designed in a way that we can derive a number of different encodings from the UML data models. So it's definitely possible to derive other encodings, and that is basically what this action has been trying to do, is to define alternative encodings to the default GML encoding. So this is one of two actions, are basically two sister actions that address this overall problem. The other action is 2017.3, that is basically looking at how we can improve client software to basically consume these complex data structures. And we will say a little bit about that as well towards the end of the presentation, but that's not the main focus of the talk today. So we will mainly be focusing on the alternative encoding part. Now, the task of the action was that had basically a subgroup with representatives from member states. Basically, had three main tasks. One is to derive an encoding rule based on GeoJSON. That should be the first example. So we really want to see this as one example for an alternative encodings that shows basically how it's done. And basically, we hope that we can motivate several of you in the member states, but also in thematic communities, to follow that example and propose additional alternative encodings based on GeoJSON or based on other formats as well. At the same time, we also discussed that it would be useful to kind of have some generic rules or approaches for simplifying the complex data structures that we have in the Inspire data models. That would be useful for the GeoJSON encoding, but also potentially for other alternative encodings. And these two basically tasks should result in two good practice documents that we want to present to you today. And in fact, we actually have even more documents, because basically we decided at one point then to have 2 example themes that we will present to you today: addresses and environmental monitoring facilities. And these again will be good practice documents as well. Yes, basically that's the third point that we have there. We have a GitHub working space, so the whole group has been working on GitHub with a number of the documents are available there, but also a number of issues and examples that we have discussed over the past year are basically available there. And as we said, we hope that in the future other alternative encodings will be proposed as well, following the same good practice procedure. Now, this procedure is something is quite relatively new, where we basically have decided that we have a number of technical guidance and of course the legal act implementing rules, but these are quite heavy procedures if we want to do an update, and it's always been a bit difficult to kind of come up to keep track with the technology advance and new standards coming out all the time. So we basically decided that it would be useful to have yet another type of document that we call the good practice, that basically describe solutions to either specific implementation issues, like how to create and maintain persistent identifiers, or also alternative ways of addressing some of the implementation of the Inspire components. Like the first one that we have is a metadata good practice for Inspire metadata using GeoDCAD application profile for metadata. Now, the procedure for these good practices is basically that anyone can propose a new good practice, starting from a good practice fiche. So that's basically a kind of a metadata document that describes why the good practice has been proposed, what's the benefit of it, including also evidence that the solution has been put into practice and that it basically has received broader support. So it's not just that's something that one person or one organization has done and found useful, but that there is, let's say, several member states or several organizations that have been putting this into practice. There should be an outreach through a webinar. That's why we have the webinar today. And then basically there will be a submission of the good practice document for endorsement, and it will then basically be published on the Inspire knowledge base once it's endorsed by the maintenance and implementation group. And then the idea is basically that on the Inspire knowledge base, we will have the possibility in the future to also provide feedback on the existing good practices, where people can ask questions and can provide feedback and say we have implemented that good practice as well. So that's basically a future plan for this repository on the Inspire knowledge base. So the next step, as we said, today we have the presentation of the documents in the webinar. We hope that then some of you or many of you will pick up this good practice and start to try and implement it with your own data and share those implementations with us. We're also looking still for feedback on the document, so if after this webinar you would like to review the document in more detail, please do so and send us your feedback by the end of May. And we would then propose the good practice documents for endorsement as good practices by the MIG in the meeting on the 20th of June. On top of that, we also have had discussions in the MIG-T recently in April. Some countries are interested in doing an alternative encoding proposal on GeoPackage. There's interest in Austria and in Spain to work on that. So that might be something that hopefully will be kicking off or has been started already for yet another proposal. And we have been also thinking of organizing a challenge around alternative encodings, either this one that we're presenting today and or proposals for additional ones on GeoJSON or for other formats for the Inspire Helsinki workshop that will take place on the 22nd to 24th of October, and that is organized around this notion of challenges. So that's an idea that we have, and if several of you indicate to us that you might be interested in contributing your own proposals for alternative encodings or testing the one that we're presenting today, we will probably go forward with that as well. So that's it from me to provide a bit of context, and I would then hand over the presentation to Torsten, who will walk us through the work that we've done in the subgroup. Up until here, any particular questions? I don't see any hands raised, so I'll hand over the mic to Torsten.
Yeah, thank you very much for the introduction. Just one moment while I set up the screen to be shared. Yeah, just a very brief moment. Okay.
Maybe I should say, if you can also, of course, use the chat to provide questions or comments throughout the webinar. We will try to get back to the questions that you put in the chat as well.
Mm-hmm. All right. Yeah, I would also like to welcome everybody to today's webinar on alternative encodings. Yeah, basically my role, as Michael mentioned, was to serve as an editor mostly, and yeah, to write up all the different resources that we've been creating in the past months. So what I'd like to do now is just to give you a quick overview of the methodology that we've been following or developing while doing this project. Then to take you through the GeoJSON encoding rule with its structure, what are the different documents and parts that belong to it, and then go a little bit into detail on each one of these. So there I will actually use the documents that are live in the GitHub repository to show, for example, what these model transformation rules are, how they pertain to GeoJSON, but how they can also be used for other encoding rules. Then what the specific rules for the GeoJSON encoding are, and how it's applied to two Inspire themes: addresses with geographical name elements and environmental monitoring facilities with observation and measurement elements. I'll then also take a quick look at whether we succeeded at making Inspire data more usable in the kind of target environments that we were aiming at, what the still open points are before we'll have some time to address any. Sorry, there was an interruption. Just a brief moment. Okay, so that's not going to happen again. Okay, before we go to any discussion and questions that you might have. All right. Yeah, so let's have a look at what a general encoding can do and how it's structured before we dive into the specifics. So a quick clarification that we also went through as a team and that I wanted to convey to everybody as well. So we all know the Inspire data specifications include a default encoding, which is in most cases GML, and in some cases for coverage data sets, it can also refer to GeoTIFF, for example. The default encoding is special insofar that data that complies to the rules of the default encoding is always assumed to be Inspire compliant, and that there is central tooling available. So for example, for GML, we have the Inspire validator with which I can do a lot of tests on whether the data that uses the default encoding actually complies to all the rules. So that's basically what we have. Now there's also the possibility to have additional encodings, which is basically something where you say, okay, I have the default encoding, but to make data more usable, I'm going to provide an additional encoding. And when it's an additional encoding, it actually doesn't have to satisfy all IR requirements, and we don't need to prove that it does so. So it's usually something that's used in a smaller scope and where less central tooling would be provided or required. An alternative encoding, however, is a slightly different beast. So here the goal is really to be able to provide a data set in the alternative coding instead of providing it in the default encoding. It might still make sense to do both, but for some use cases it can be much easier in the sense of lowering the implementation hurdles of Inspire to provide the data set directly in the alternative encoding. However, for that to work, the alternative encoding for a particular data set needs to satisfy all the requirements laid out in the implementing rule. And to some degree, the data owner also needs to prove that it's actually compliant. if requested at least. For the alternative encoding, we are expecting a lot of the tooling to also come from the community at large. So companies like ours may contribute to that, but also many of the data providers can actually work together to develop such tooling for the alternative encodings. Like, for example, how can you validate whether the content that's provided in such an alternative encoding actually complies to the rules. So just to summarize this important distinction, an additional encoding is something you can always do on top of the default encoding, but an alternative encoding for a given data set might actually be able to replace the default encoding. Yeah, and while we're on that topic of general requirements for encoding rules, there is actually a couple of statements in the implementing rules that define what requirements there are for encoding rules. And yeah, it's this statement here that I've put in italics on the slide. So every encoding rule used to encode spatial data shall conform to EN ISO 19118. In particular, it shall specify schema conversion rules for all spatial object types and all attributes and association roles and the output data structure used. So I'm highlighting this because you will find exactly these terms later in the outline of the GeoJSON encoding rule. Yeah, so those requirements basically say that we have to take our conceptual model and describe how we derive the particular schema for the given encoding in detail. And yeah, there are some additional rules, like for example on spatial reference systems. There's also a statement which character encoding to use. And yeah, me having to work with a lot of different data sets, I can tell you that character encoding problems are actually one of the most common issues we encounter. So it's really beneficial not to try to do something else in a different encoding here. Yeah, then finally, there's also a recommendation for alternative or for any encodings, and that is that encoding rules should be based on international, preferably open standards. That doesn't rule out things like file geodatabases or shapefiles or the like. It just says that we make the recommendation as a community that using open standards like GML or JSON or GeoJSON, which is specified by the IETF, is preferable because it enables these encoding rules to be made available and without any strings attached from a license perspective. So how did we actually define the alternative encoding? Well, first of all, I think it's always really important to understand why we are doing that. So at the core, what we are usually trying to do is to solve a problem. So for example, with a default encoding with GML, there are several issues that to varying degrees have impacted the data usability. For example, a complex GML file can usually not be loaded directly into a GIS like ArcGIS, let's say ArcMap, or QGIS or a WebGIS, which means that I do have to put some intermediate processing to put it, for example, into a database with which I can then work reasonably well. So we really have to say, okay, there are these specific problems that keep us from using the data as we need to use it. So that's what we try to solve. So definitely describe what the technical issues are that you are going to be addressing with that alternative encoding. The second thing is also to describe the scope then, or the third point here actually, so that you say exactly what kind of themes and use cases are you building this for. So for the GeoJSON encoding, the focus was very much on being able to have like the typical core GIS use cases like viewing, styling, and analyzing data in a desktop or web GIS at the core. And we also limited it to certain themes. So we, as I mentioned before, we made the decision not to try to find common rules for all 34 themes in one go, but rather to take two themes that have certain characteristics, like one is Annex 1, one is Annex 3. Both are very common high-value data sets that are implemented by a lot of organizations, but also have some tricky parts in them, like the address components and the sensor observations in these two models. And those are the ones that we want to particularly make more accessible at the same time. So the what is then the second stage, and that's basically given that we said, okay, we are creating the encoding in this way because we want to achieve this and that. We know the logical model of our encoding, of our format more or less. But what do we now need to do to the model? So we all know that we have a UML model that has quite a lot of structure to it. It's basically, it uses all kinds of conceptual associations, it uses inheritance and so on. And we will need to break that down to some way so that it matches the format logical model well. These model transformation rules and also other specific encoding rules need to be defined. And that's basically the process that we also underwent through. So we went through the original model as well as through instances that represented that and solved the different issues and how to map that to the target structure and solving the problems that we want to be solved one step at a time. Then at the last phase, the question was basically, how can this encoding be implemented? Are there any specific tools and help and so on that we can give? Can we create an executable test suite or other resources that help with this particular encoding? Yeah, in our current stage, we are somewhere in the between 2 and 3. So I would say a draft of the specific encoding rule and of the model transformation rule is complete, pending your feedback. And now we are working on, let's say, removing some of the issues that still are there in the implementation. Like, for example, it's of course always a compromise. And there are still a few minor issues that don't work in the GIS software as we would like to see it. And so, the question there is, do we iron those out of the encoding or of the software themselves? And that's to be seen. Okay, so let's have a quick look at the structure of an alternative encoding. So if you think of this as a document that you have to write potentially, so we basically took the following structure. So there's a bit of background that explains more or less who's been doing this and why. The scoping, so what kind of use cases, inspire themes, and potential other requirements are in scope of this particular encoding. We have a reference to terms and definitions, so there's a shared glossary for all alternative encodings, because our hope is that we don't have to redefine all these things all the time. Then, of course, there's the normative references. Like I said before, it's preferred to base this on an existing published open standard, so there could be reference there. And then there's the schema and the instance conversion rules. Optionally, it's also possible to have examples as well as some test suits, as well as the model transformation. So where they are required for simplification, for flattening, you can reference a number of these model transformations. Yeah, one thing that's also important in our experience already is to make the specification modular. So this is kind of the one document approach here, but as you will see for GeoJSON, we quickly discovered that it makes sense to break out things a little bit, so that small working groups that pretty much like the thematic working groups used to do it can work in a more independent fashion. And for example, bring forward the version of a particular alternative encoding quickly and without having many blockers from other documents there. All right, so that's a quick intro into the how did we approach this and what the general structure is going to be. We are currently in the last stages of putting together the resources. So if any of you want to go through the same process, that you have the description and the templates and so on at hand and can do that yourself. I expect this also to be completed in the next 1 to 2 weeks. So it would be available. And I assume both the team at the JRC and us would be able to give you some pointers where to get started. Okay, so having said that, I would like to move on to the actual GeoJSON alternative encoding. Specifically, like I said, what the document structure is, what the general encoding rules are, and how we've covered 2 Inspire themes there. So let's take a look at the components of the GeoJSON encoding rule. So the main document is actually this, the Inspire UML to GeoJSON encoding rule. So that specifies how we go from the conceptual model to GeoJSON, basically. It references a glossary, and it also has some additional parts, but these are actually forward referencing. So we have the two theme-specific GeoJSON encoding rules, addresses and environmental monitoring facilities, which actually point to the general Inspire UML to GeoJSON encoding rule. The intent here is that you could also create another GeoJSON theme encoding rule without the main document requiring an update. Like basically this way, these documents can all live by themselves. They can have individual versions, and you can just add one. You can say, okay, I want to work on cadastral parcels, for example, and create your own encoding rule for that purpose. The encoding rules, the theme-specific encoding rules, also reference model transformation rules. That means that each one of these actually has like a procedure described that tells you which model transformation rules to apply in which order and with which parameters, so that you can go from the Inspire conceptual model to a simplified model that can be encoded as a simple GeoJSON object. There are also example resources available in the repository, which I'm going to walk you through later. And of course, there's the glossary. So the glossary can in principle be referenced from everything. I only included the link from the main document down here, as well as from another encoding rule. But the idea is, like I mentioned before, that the glossary should actually be reusable, and it should be shareable by multiple encoding rules for alternative or additional encodings. Okay, and with that, I would actually like to go to the first document. Just a moment. I think Michael mentioned the URL of this repository already. So all the documents that I'm going to talk about live in this repository. And if you find anything that you would like to discuss, or you find an issue, an error, something that needs to be changed, there are two ways. You can either just create an issue on top of this here, or if you think you have a proposal how to directly fix that, you're welcome to also create a pull request for getting this change in. Generally, the idea is that this repository will be home to more than one alternative encoding. So right now, there's this folder for the GeoJSON alternative encoding, and there's a folder for the model transformation. So again, these model transformations should be somewhat independent of the actual alternative encoding and are ideally reusable across multiple encodings. Like maybe if we do a simplified GML encoding, at some point we could apply the same ones. So the examples that are listed here were actually input examples, so things that went into this design process. The actual examples of the encoding are to be found below this folder. And there's also the template, but this still needs to be updated before you can use this. Okay, so let's go into the GeoJSON encoding. So the main document here is this Inspire UML to GeoJSON encoding rule. Yeah, we looked at the structure roughly before when we looked at the template already. I think the key things here are really the conversion rules. Other than that, we have already provided a bit of preface through this presentation. So here it's basically an explanation of what the mandate of the group was, what the decisions were that were made. And yeah, after that, we hand over to an introduction to GeoJSON in particular, and to what should be achieved with Inspire. Yeah, the first thing then was to discuss the scope, particularly, as mentioned before, that we wanted to enable users of standard GIS software, be it desktop or web, to effectively use Inspire data for mapping and processing and similar tasks. Yeah. In the end, at least for an additional thematic encoding that should live in this particular repository, or you actually maintain it in another place and reference to this. This would also be possible. Things that we wanted to address that were really important to us were, for example, that most GIS have problems with attributes. They have problems with complex properties, like, for example, not displayed properly, you can't use them in styling, you can't use them in filtering, etc. So these things should be solved. Also, references can often not really be resolved. So if you're using these href elements to indicate that objects are linked in some way, this information is often not directly usable in GIS software. We also had encountered issues where many geometry types could be present, even mixed ones, that some software will have issues dealing with that. And aspects like mixed geometry types can also be problematic. There are still some technical limitations, so we'll also have a quick look at that again a bit later when we come to the testing results. So for example, GeoJSON cannot deal with 3D geometries or with coverage or raster data effectively. So I wouldn't expect to be able in the future to have building 3D thematic encoding, for example, in GeoJSON. This one we already went through, the general Inspire requirements for an encoding rule. In terms of the normative references, it's clear it's GeoJSON as an IETF standard, and also the general guidelines for encoding of spatial data that we are referencing. Now, when we come to the meat, the first thing is actually the schema conversion rules. So here we have a somewhat difficult situation because compared to XML schema, there is not as an expressive JSON schema language. That's really a one-to-one, let's say, equivalent to XML schema. There is JSON schema, which can be used to perform simple validation on JSON documents, but we decided not to use JSON schema, normatively at least at this point, simply because it's also not supported or used in any of the targeted GIS tools. So from my perspective, the preferred approach right now would be to create an Inspire data set in the default encoding and then convert it to JSON to know that the principal requirements were met before. So the validation is not done on the GeoJSON, but actually on the XML before. Yeah. So here in this particular rule, coming back to JSON, what we decided to do is to take a two-step approach where we apply the model transformations on the level of the conceptual model, and then we actually encode that simplified model in GeoJSON using the rules described later here. And yeah, in terms of how that's done, it's basically described here. So for example, types that have the stereotype feature type are actually converted to GeoJSON objects. So a GeoJSON object has a top-level property called geometry, which contains the actual coordinates and so on. Whereas other types are converted to regular JSON objects, and where all properties are directly added to the root object. Yeah, this then also describes how certain basic types, like character, string, and so on, are mapped to JSON data types, how the geometry types are mapped. So here it's important to realize that there are some, let's say, differences. So for example, primitive is at this point not, abstract types are basically not supported. And the tin is at this point also not supported, just as an example, as well as the aforementioned 3D meshes. Yeah, there's also references to metadata types and to temporal types. There are two proposals to have a simple period and a simple citation. Especially for the latter, there's still a bit of discussion whether it adds sufficient value for the citation types like legislation citation that are already in Inspire or not. So this is something that feedback would also be appreciated on. That also describes how to deal with some of the more complex constructs like union types and abstract types as property types and the like. And yeah, basically describes step by step how you go from a model from the conceptual model to a model that can then be mapped to JSON, to a simple JSON structure. Yeah, we do the same for properties, for association roles. Just a quick note, I think that one's a bit special. We decided not to convert the stereotype voidable, and if a property has no value, it may simply be dropped. There is a rule related to that at some other point that we can have a look at then, which is basically that if you want to include nullable, well, nil reason information, sorry, you have to maintain that on a dataset level. And if you really have nil reason information that's object specific, feature specific, you wouldn't be able to use this GeoJSON encoding. Yeah, so after having a look at the schema conversion rules, there's the instance encoding rules. And here we really go into looking how we deal with certain issues of encoding the actual data. So the obvious thing, for example, is the character encoding. And for coordinate reference systems, there's also a special rule in here. So as you probably know, Inspire has a list of spatial reference or coordinate reference systems, out of which one needs to be chosen. Whereas GeoJSON in the final specification actually only allows the World Geodetic System 1984. And so due to this particular limitation, we looked into how we can resolve that and decided to basically map this to one of the Inspire CRS. So there is a certain loss of absolute precision related to that. I think we looked it up. It can be up to 1 meter, if I remember correctly. So for data sets where this is not acceptable, again, the statement applies that the GeoJSON encoding would then not be the right encoding to use for this particular data set. I think there was somebody who raised a hand. Should we be quickly addressing that, Michael, or later then?
I'd suggest we do the full presentation first, and then we'll answer questions.
Okay, good.
So please remember your question, or maybe put it in the chat in the meantime, so that we can have a look at it. Thanks.
All right. Okay, as you can imagine, this was also one of these points where there was actually a lot of discussion, especially because there is also alternative coordinate reference support in some tools. That's based on an earlier draft specification of GeoJSON that's also linked here. So draft 6 of the GeoJSON spec actually had the ability to define an alternative coordinate reference system to indicate that, for example, you're using a projected coordinate reference system or another one. And so we do also have a clause in here that basically says that in some situations you may use that, in particular if it's explicitly requested. Yeah, I mentioned the nil reason information above briefly already. So basically the idea is that in the GeoJSON encoding rule, to keep the data structures compact and also not to have all these attributes present in the system or in the GIS then, we do not keep nil reason information per feature, but only for the whole data set. The other thing that we also addressed was identifiers. So a GML feature has 3 properties, potentially 3 properties that identify it. So there is usually the GML ID. There can also be an identifier, and there can be the Inspire ID. And this particular table describes how that's typically mapped and what we retain. But the main thing is, so we do expect the ID still be present, but the identifier can be omitted if empty in the source object. And the same is true for the Inspire ID itself, where it's present. Yeah, so that already takes me to the end of the Inspire theme encoding of the main document, because it basically just defines the general rules that we hope can be applied to all the themes that want to use a GeoJSON encoding. I'm pretty sure that with your feedback and ideas, there's going to be a few changes to some of these places in terms of specifically of the schema and instance conversion rules. We might find more and enhanced rules here. Yeah, or things that simply can't be aligned with the needs of a particular theme. So if we go back, the other structure that we have, or the other folder, go quickly here, that I wanted to take a quick look at is the glossary. So we also have several terms defined, which we can find directly here in the root. And yeah, if you find that you need any other terms for your particular encoding that you'd like to add, this would be the place to add it. So for example, what I introduced at the beginning, the difference between an alternative and an additional encoding rule is listed here. We also describe things like what a bijective transformation is. So basically that's the ability to transform data from the default encoding to the alternative encoding and back without a loss of information. And yeah, there's a number of other terms that are explained here that I hope will also be useful for other teams working on this. Okay, that takes us to the third general part. So, which is actually the model transformations. So the model transformations, there is at this point, there is an introductory document on those, which describes what the purpose of the model transformations is and what element each one has. So in the end, we decided that this is simply more or less a catalog of rules that you can apply or can't, that you can combine them in any way that's meaningful for you. And yeah, there's a catalog of these. There's currently 9, sorry, with relatively general ones and also some more specific ones. So for example, there's the general flattening of nested structures. That's more or less what you would also expect. So we take any complex nested structure, like here, management and restriction regulation zone, and then we flatten that. So we take the different elements here and we make all of them flat. That means that there's no nesting anymore. But otherwise, things are pretty much retained. Yeah, and the model transformation rule also has parameters. In this case, it has 1 parameter, and it's the separator. So the separator is this particular little character here. And yeah, we decided now to, by default, use the dot, but we've also seen others that have used underscores and the like. That really depends on what your target platform allows. So if your target platform doesn't allow dots in the names because it's a protected character, and you need to use something else. Yeah, it also describes whether there's a specific instance transformation rule, and it addresses which kind of issues this actually solves and still retains. So one thing here, for example, is that if you have very deep nested structures and your property names are very long, you could actually run into some property name limits. Like for example, some databases only allow for 63 characters in the column fields, or for 250. That's another limit. So you have to make sure that whatever your target environment is doesn't actually run into these. But usually the limit is more of a practical one, because property names that are that long are really hard to understand, to use. So yeah, it's more or less a transformation rule that's very general, that helps with making things flat at the end. But usually the objective is to combine it with other rules to not have too deep or too long strings for the characters, for the column names or attribute names here. There are also other rules. For example, there are ones that allow us to deal with structures like the ones we have in addresses. So in addresses, we actually have the address components, and an address component can have a different type. So it can be a thoroughfare name, a postal descriptor, etc. And what's happening in this particular rule is that we take this whole structure, and basically inline the actual elements that have been referenced before. So here, for example, we have the postal descriptor and the address area name and so on as simple properties using a certain pattern of naming here. certain naming convention. I'm going to go into a bit more detail when we arrive at the two examples afterwards. So yeah, but the general idea is that this is the place where you can also put any model transformation. So you can, if you find that one of these is helpful, that you would like to use that as part of your additional or alternative encoding, then absolutely, you're welcome to do so. Or you add rules. But generally, I think here we should also try to reuse things where it's possible, even if it means making some smaller changes to one of these to make them more general. I mean, right now they are only representative for two, for two themes. So it would be really good if you have some input how to change or enhance them so that they would be useful for others as well. Okay, that brings me more or less to the next part. That was the model transformation rules. Yeah, like I said, so if you write one, you should follow this particular template. Yeah, and then we have the examples. So I think people really like to look at examples, me too. And just a moment, switching back. Yeah, so in the examples, the idea is that we really directly start from something that can be used. So we have concrete data that actually is something we can load into different software and see what the issues are that appear.
Thorsten, can you zoom in a bit?
Yes, absolutely.
Thanks.
I was actually planning to do this for a moment. So, and yeah, basically these examples are intended to be more or less used and test material for the testing later on. But we also use them a lot for discussion directly. And if we now zoom in a bit, that's what it looks like. It's really a minimal example of a GeoJSON feature collection that has one feature in it. And yeah, as expected, here's the geometry. That's a point, so it's really simple case. And then we have the properties. So that's a normal GeoJSON object, has exactly this kind of structure, that you have the geometry and the properties as top level properties. And here's where all the things have ended up that were encoded in the Inspire objects before. And as you can see, now we actually have one object. So all the address components have been folded in. Effectively, that means that we have effectively denormalized the model, of course. So we're probably going to have far more repetition, because all buildings, for example, that are in this particular postal descriptor will now have this particular property instead of referencing to one shared object. But there are always some prices to pay, and this is not the only one. So in the end, it's really about, do I have a simple object? Can I directly use that in an environment like this simple preview feature here, or a desktop GIS? And that was more or less the goal here. Yeah, and the other thing is that here I can now easily filter, for example, addresses by things like where are they? Is it in Hessen and Darmstadt, for example? Whereas before you would always have to evaluate the relationship between different objects in the default encoding. All right, so that's the example more or less. Let's have a look at the actual theme-specific specification. So first one that I'm going to take a look at is the addresses one. So addresses is pretty much considered to be a very high value data set that's used for a lot of different purposes. It's typically one of these things that is really, really used as reference data in many contexts, which is a reason why we thought that it might make sense to pick this one. Yeah, we've also decided to use it because it makes use of geographical names, and that's a particular element that, is for some situations it's really applicable in the way that it's been specified, but for many use cases, let's say its overhead is simply a bit too high with the spelling and official and so on. So you can have a lot of attributes that for many applications are simply not that relevant. So here we basically said that we're going to simplify things a bit. Specifically, we said that the simple addresses encoding can be used as an alternative encoding for address data where there's only one geographic name for all elements that use it. So it, for example, it doesn't address multilinguality at this point. This is something that could be modified or extended if we find the need later on. It also says that there is only one administrative unit name address component per administrative unit level, and there's only a single default position per address object. So in principle, you could have also multiple positions per address object to indicate different, let's say, for example, the building entrance and the entrance into the parcel and so on. But this is simplified out here. Yeah, the document itself is structured in such a way that, again, first there's the normative references. Obviously, it refers to the general UML to GeoJSON encoding rule. And it also refers to the data specification for Inspire addresses. And then there's something that I would also like to explain. We decided that also in the sense of making this modular, that we would actually have one conformance class per schema in a theme. So, you know, some of the themes, like for example, transport networks have multiple schemas. And yeah, for those, you would actually have multiple conformance classes, but in addresses, it's just one. So it's the core conformance class. And this class describes the model transformation by actually referencing the various functions that we've looked at before. So if we go back to the model transformations, to these different rules, those are actually referenced here. So for example, the first thing we do is we substitute all occurrences of geographic name with a simple geographical name. Then we substitute all attributes that have a property type with a codeless stereotype with another function and so on. So we basically apply a number of these transformation functions on the model in a certain order. And the last one is almost always the general flattening rule. So whatever structure remains, or nested structure remains, is going to be flattened using this particular rule here. Then the next part that's in this theme-specific document is a model mapping. So you might remember that we had this requirement that we need to provide a mapping between the conceptual model and the encoding model here. And that's what's provided in detail in this particular table. So it basically says that, for example, the field alternative identifier from addresses, which has the type string, is mapped as follows. So for most purposes, it's a pretty one-to-one thing, but it gets a little bit more complex in these cases here when we come down to the component. So for example, if we have a component in the source model that has class thoroughfare name and type component, we actually create a thoroughfare name, a component.thoroughfare name property that has the type string. And there's many more of these. We do something similar with the locator model, where we are also mapping out to a lot of specific properties. Yeah, and then there's a couple more. So for example, here position is also special because the actual geometry is added as geometry to the root object, but we also want to maintain additional information such as the specification and method and whether it was the default position. So we regenerate a set of additional properties on the JSON object. Yeah, and then we also have a number of again, we're looking at the examples. So those are also part of this document. We have the examples in here. I think here it was one exactly. But there's also a link to the actual file that we've seen before, which is here. Yeah, and let me know afterwards if you have any particular questions on this example, but in the end, what it is it has a single level of properties here, so it can easily be read into most software that can process GeoJSON. So this particular structure, we only found one issue, which is when you have many objects that superimpose the same geographic location, some software can't really deal with that well. So it could be a problem if you have many objects that take the same space because, for example, they're all in the same place or all addresses from a big building with many different floors and so on. Yeah, so that can be a kind of a challenge. So that's the addresses one. There's also the environmental monitoring facilities example. So the structure here is the same. There's also some limitations, but yeah, I think for most reasons or for most situations, they don't matter that much. So right now, for example, only one legal background document can be referenced, and the measurement need to be one of the following. So in principle, if I remember correctly, you can also have other types of measurements and results in there, but we're limiting it to the types that are also defined in Inspire and a very simple result. That's basically a single primitive value. Yeah, here again, we have the same thing, one conformance class. And yeah, the question here was also how to particularly deal with the observation and measurements types, because these are actually pretty complex and there's a lot of information in there. But luckily, one thing that was very good for us was that there is already work done by that. So there's a simple features representation for OMSF, and there's actually also an OMSF GeoJSON model mapping already. So if you want to, we can have a quick look at that. So this can be found also on GitHub under OMSF profile, and it describes in detail how to do this encoding for these particular elements. And we've more or less reused exactly that. So because this is really a big block of work that's done there already, and yeah, we were happy to be able to apply this here as well. For the other elements, again, there's a model mapping being done here. So we have quite a few of types here, the environmental monitoring activity, facility, and so on. Some of these also, again, have these filters, like, for example, what do we do if it's one observation? What do we do if it's multiple ones? And yeah, we go through all of these different types, mapping the types that we have in the conceptual model to those in the simpler model. So let's maybe also take a few moments to look at this example. The first one is really the simplest case. So we have one environmental monitoring facility with a single measurement result. So the example of such a structure is that it really always works in an easy way. And I can directly use the result, for example, for styling purposes. So this works in any tool that we've tested it with. So basically what we're doing here is to really fold in all information related to the observation into the main object. So we have really just one object and not a reference or an aggregation between the environmental monitoring facility itself and the actual observation. That's a bit different in the second example. So the second example has, first of all, again, an environmental monitoring facility, but it actually has a second object, which is the point time series observation. And in this case, there is actually a reference from one to the other, which uses the same structure that we have in the default encoding. So there's an has observation, href, which links to the ID of the other object. So here we still have the problem that this is actually not directly supported by any of the GIS software that we tested. So that's one of these compromise things. However, it also means that this particular object could still be relatively lightweight and usable directly. However, the actual observations are in a different feature. That different feature at least also has the same geometry, so it could be shown on the map, and it has a lot of specific information to the procedure. The main thing here, however, I think that's kind of special, is that we decided to keep lists or arrays. So the reason for that being is that especially in OMSF as well, it's done in the same way, but it's really, it can easily be thousands or 10,000s or millions of values. And if we actually create an attribute for each of these, there's a lot of systems that will quickly have problems with that. So we decided here also to principally keep the list with the different time steps in this case and the results. There are also some downsides to that. So not all GIS software understands these lists. And if it does it, there's usually some limitations. So for example, in QGIS, long lists are truncated in display in the attribute table and on the identify tool. So I wouldn't be able to see all values. There are also other issues, like for example, it's a bit harder to actually access these values through things like the field calculator and so on, but it's at least possible. So in our view, this represented a compromise in terms of the format, where some probably not that big work, but that's exactly one of the things we need to find out, is going to be required from the tool vendors. Yeah, so those are the two examples that I wanted to look at with you. So let's go back to the presentation. So what you've seen now is basically all the documents that are a part of this GeoJSON specification. So there's the general UML to GeoJSON encoding rule. There are the theme-specific ones. There is the examples, and yeah, there's the glossary and the model transformation rules. That's what we have now. However, there's still some work required. First and foremost, there are still a couple of editorial changes and fixes required. There are also a couple of issues in the GitHub repository that I think we should either address or close, but definitely resolve in some way. And I'm also looking forward to addressing any changes and requests that you might come up with. So this is now being presented in a much larger community, and I'm pretty sure there's going to be some valuable feedback in the next weeks. Yeah, and then after that's done, the idea is to accept this document as a good practice and release it with version 1.0. You might have seen that we tentatively currently give it 0.1. Yeah, and more or less as a last block, I also want to quickly look at how we are going, or how we are testing this. So basically the intent is that going forward, we continuously test encodings, both the default encoding and any alternative ones, on how well they can be used and what problems are there. So I think this is also part of really achieving interoperability, that we don't just throw out data there, but we really try to make sure that all the parts fit together nicely. Yeah, and for that purpose, in November and December, we defined a lot of test cases. There's another repository that you can take a look at. And yeah, we would also like, if you want to, you can also contribute test cases and especially test data sets. And we then mostly did manual testing. So these software like ArcGIS and QGIS and the like doesn't really lend itself to a lot of automated testing in this kind of area. So right now it's a lot of automated work. We then document the results in a specific JSON format. I guess we had to do that since we're doing the GeoJSON encoding. And from that, we then generate readable documentation like this, for example. So this is basically a table where you can quickly see whether a certain test was executed successfully or with some limitations. And for that, I quickly switch to the browser again. So here, that's the representation of this repository. And we also have the results, for example, for all the GML tests here. So you can see directly that, for example, loading a large file seems to work everywhere, so that's fine already. Here's some geometry display issue in Hail Studio, so you can also click on these and then get more detailed information on what the actual issue was. And in this way, we intend to share continuously really what issues are where, how can they be resolved, and yeah, generally really make it well known what the problems actually are so that we can address them from different sides, one being the alternative encodings, the other one being enhancements to the tools. Yeah, so some of the things I've mentioned already, so multi-type collections in QGIS, for example, seem to be an issue. So it basically uses the union of the schemas of all types in your collections, and that can be really confusing. And we also need better support for arrays in an attribute table, just as an example. So we're going to collect those. There's going to be a meeting in June with the vendors to actually discuss how to move forward on these enhancements. And I'm optimistic that we can then really basically have a good fit of our Inspire GeoJSON and the tools that are out there. Yeah, and that's more or less the conclusion of my presentation. So Michael also mentioned that, and I also gave a couple of points where I think it makes sense for you to contribute with your questions, with any ideas, discussions. And then also, of course, later on with contributing to the existing repository, with creating implementations and reporting your experiences from those, and then also to add theme-specific encoding rules or other alternative formats. All right.
Okay. Thanks a lot, Thorsten. I think there was a lot of content to be digested, but I think you've explained very well all the work that we've been doing over the past year. And I also wanted to thank at this point Thorsten, of course, for being the editor, but also the subgroup that has been contributing the example, has been discussing, and basically has been doing all the work that is now basically summarized in these documents. And some of the people, the members of the subgroup, are present on the webinar today. But also when you have the discussion now, if you feel you would like to add anything, please let us know. Okay, I think we already have collected a few questions on the chat. I would open now the floor for discussions. Maybe we start with the ones in the chat. If you have other questions, maybe just put a +1 in the chat or post the questions there, so that we can basically give you the floor to ask your question. The first question we had, not surprisingly, was about the coordinate reference system, which was one of the topics that we basically had a lot of discussions on also in the group. The question from Bernd was whether there is no requirement in Inspire to make data available in another CRS than GeoJSON 84. That is almost correct. I will maybe just share. Let me just take the screen again. Mm-hmm. Okay. Maybe just share again the point in the specification on the coordinate reference systems. Okay. You help me where it is. Oh, here. Okay. So basically, we discussed a lot about whether we should allow different coordinate reference systems. But we basically agreed that in order to have standard tool support for the GeoJSON encoding, we should live with what is specified in the standard, and that is WGS 84. Now, if you look at many on how most of the GIS tools deal with the difference between ETRS 89 and WGS 84, you will see that basically there is a one-to-one transformation. So, for example, if you look into the EPSG database, you will see the transformation from one to the others is basically a one-to-one transformation. So they assume it to be the same, basically. And that is basically, it says here for this transformation that they are coincident within 1 meter. Okay. Now the question, or what we basically then put into the document here, is that if that accuracy is enough for your purposes and for your data, then you can use the GeoJSON encoding as the default, as the alternative encoding. But if it isn't, because, for example, you have cadastral parcel data that are more precise and that cannot deal with this kind of precision, accuracy, then you cannot use it as an alternative encoding. Okay.
You could still use it as an additional encoding, just to clarify that.
Yeah, exactly. And that, I think that nicely explains the difference between what is an alternative and what is an additional encoding. Okay, then there was another question from Bernd. I think that was already answered by showing the examples. That was about the need to have the Inspire ID attribute. That that is still included in the encoding. So basically we have a mapping here from the Inspire ID attribute in the conceptual model to 2 or 3 properties that are kind of flattened out in the GeoJSON encoding to show that. And that was basically also shown in the examples that Thorsten showed. Okay. Then there was a question about the address area name feature type and how that should be encoded as a reference in GeoJSON. Now, that is an example where basically we have used one of the model transformation rules, Thorsten, right?
Yes.
To basically include that in the address feature type. So one of the other reasons why we choose the address data model was exactly the fact that it is a kind of quite a normalized data model in the sense in the UML conceptual model, is that it basically creates features of different types for all the different address components. So you have the address area name, you have the administrative unit name, you have the thoroughfare name, and so on, that are all individual objects, and then basically the address object is basically put together by providing references to all the different kind of objects that you have in your address database. And what we've done in the GeoJSON encoding, as Thorsten also explained, is basically to denormalize that model, conceptual model, to include all the different components of the address into the address object. Maybe we can have a look at the example again. So if you look at the example here, you will see that there is a number of component properties here that basically are all these component relationships in the conceptual model. And we have the different types of the components. So we have a thoroughfare name, we have a postal descriptor, and we have the address area name. So the reference to the address area name is really created by providing a property called component.address area name with the value, and we don't have a standalone object of the address area name. Then, Thorsten, if you want to explain a bit about the simplification rule that was being used here.
Yeah, so if we go back to the root, then to model transformations. So I think that's the top one. Yeah. So basically, here the intent was, this rule essentially does 2 things. So the first thing it does is it describes how to combine multiple features into one. So basically, that's the denormalization step. And the second thing is that it describes a pattern how to name the properties that are created in this way. So using the type name, essentially here, for example, we have this component thoroughfare name. So it takes the original property name and then adds a separator character and then the original type name. And it also describes, for example, if we have multiple administrative units, how we deal with that. So in this case, we make an underscore and an index.
Okay, just see here in the chat that basically Pavel was asking more about the more general question on how to produce references in GeoJSON. Again, I think we've seen an example in the observation case where we have included a reference from the station to the observation. But as Thorsten also said, this is not necessarily being picked up by tools. Yet, should we say?
Yeah, so I think here with the discussion that we had was also whether we use something like JSON pointer, but I believe the decision was that basically since none of these is really supported in any of the software right now, we keep the string as is, the local reference in this particular case, and so at least make the transformation easier until we have a proper solution here.
Okay, thanks, Thorsten. I'm just going through the. We can see if there's anything else. Okay, I don't see any other questions in the chat. The last one.
There was one on the production.
Yes. Okay. Can you say something on that, Thorsten?
Yeah, okay. So we didn't really focus on the provision, and I think that it would be reasonably easy to create this kind of data if you already have data in the default encoding. So for example, for Hail Studio, we are actually adding a capability to do some post-processing. Basically, that applies the same model transformation rules to simplify the data structure and then to write out the JSON. Whether that could also be done just as an example, as a configuration for app schema, is something we'd have to look at. Otherwise, I think you could simply take this data, put it in GeoServer and serve it. Since it's not complex anymore, I think it should, generally speaking, be easier to realize a service that delivers this data than it's with the complex GML.
Okay, thank you. Any other questions from anyone on the call? Okay, if that's not the case, I would maybe just wrap up with, again, summarizing the next steps. So we would really welcome if everyone or many of you on the call will now basically go and have a look at the documents and basically try and implement, well, first of all, review the documents and provide us with any feedback or things that are not clear through the issue tracker. So if you go to the repository 2017.2, you will see that you have a number of issues that we discussed in the subgroup, and you can provide a new issue here. I think there were a number of templates that we used during the group work. I think we will rework those to make sure that we can use them as basically generic issues. You can always just open a regular issue here and provide your feedback or questions on the documents here. But we will maybe provide some further templates that can be used to make sure that we know which document you're referring to and what kind of comment you're making. So please provide us with anything that you see from reading the documents, but please also provide us with examples. So if you manage to implement the alternative encoding with some of your example data, please share those examples with us. So as said in the beginning, it's important for the good practices that we want to propose to the maintenance and implementation group that we can show that they are actually have been tested and are being implemented. And please also share with us if you have any plans of using this alternative encoding to share your Inspire data in an operational way in the future. So I think that would be useful feedback for us as well. And plus, if you discover any bugs or issues when you're doing the implementation, please also make sure that you share that with us. As I said, we will then propose the documents for endorsement by the MIG in the June meeting at the 20th of June. So we will try and collect as much feedback as we can by the end of May so that we can basically send a revised version taking into account the feedback for the June meeting. Also, if you are interested to develop your own alternative encoding, either based on GeoJSON for other themes or based on other formats like the GeoPackage that we mentioned at the beginning, please again get in touch with us and let us know about those plans so that we can we're aware of these things and we might be able to get you started with it, as we said in the beginning. We will not be able to kind of do the same exercises we did with the subgroup for the GeoJSON, but I think we can basically provide you with let's say templates and with some advice on how to get started if you have any interest. And we would be of course interested to know what your plans are to develop these encodings. And we might, as I said, be setting up a challenge on this topic for the Inspire Helsinki event in October. So that's it from me. I see there was some discussions going on the chat in the meantime, but that seems to be answered. So if there's no other questions, I would leave it here and thank everybody for attending today. And again, thanks to Thorsten for the presentation and all the subgroup members for their tremendous work on this, I think, really exciting project that we did over the past year or so. Thanks, everyone, and have a good afternoon and goodbye.
Thank you very much, everybody.